Yeah, and we're out of potential snow days for the week. That's so depressing when it happens, doesn't it?
It's just icy outside.
Yeah, we have hopes for next week. All right, so let's take a look at this one. And then I have a couple in the book, actually, that you're going to do for homework tonight. All right. Now, I went through this in my head, but I didn't write it out, so you're going to have to be on your A game for this. The book shows the graph of the piecewise function for negative 4 to 12. The function g is defined as the integral from x to 2 of x to 2. Does it have a relative minimum, maximum, or neither at x equals 10? Okay, so let's state something somewhere on the problem. Find something's relative max or minimum, I want to find its derivative, correct? All right, so what should I write down? If g of x equals this, g prime of x is equal to f of x. Okay, so how do we find if something is a relative minimum or relative maximum? Derivative, and find where its derivative is doing what? Changing signs. Okay, so if the derivative is changing from negative going down, the function is going down, to positive, that would be a relative minimum. Okay.
Oh, that's kind of dirty.
Okay, it's not kind of dirty. What do you think?
I don't think it's anything.
It isn't. Okay, here's where this is getting people. Some calculus students who just memorized that they occur at the zeros of the derivative would get tripped up for this. Because at 10, the derivative does hit 0, but does it change signs? Okay, so we're going to write A is neither, since f prime of x, which we are going to state, prime of x, which we're going to acknowledge here that we know what it is, because they might give points for that, which is f of x, so it knows what we're looking at, does not switch signs. Okay, again, we got to organize ourselves here. B, does the graph G have inflection at x equals 4? Okay, so what are the two calculus ways we tell points of inflection? One involves the derivative, one involves the double derivative. Okay, so Shay says when the first derivative switches from increasing to decreasing or decreasing to increasing, that is one way. Or where the double derivative switches signs. Okay. Now, I am going to use the derivative because that's what I'm given. So, at x4, does this switch signs? Not signs. Does this switch from increasing to decreasing? Yes. Does it matter that there's a corner there? No. Points of inflection can occur where the derivative is undefined. Okay? So my answer to that is yes. Since g prime of x, and as long as I stated it earlier, I'm good. Switch from increasing, and so that I'm going to put in parentheses there, I understand that means concave up to decreasing. So then it's now concave. Yes.
Usually, do you find yourself with a little bit of leftover time on the responses, so like have the time to put like concave up, it should be like just.
Make sure you write it in there. The more you can write, the better.
But you don't think that I would run out of time? Is there anything?
Where you're going to run out of time is when you don't know how to do something and you're taking time on it. And so we'll talk about that when we get closer. Like, when you're using a strategy, if there's something you really feel like, oh crap, I'm not sure how to do this, I suggest moving on and coming back to it. You don't want to. What if you in the next question you know everything and then you ran out of time? Do you know what I'm saying? So. In general, last year we spent so much time doing free responses. My students, none of them said they had any issues with time on the free response. They had issues finishing the multiple choice on time. So then that tells me, okay, I maybe need to do some work with you guys when we prepare about that. Sorry, I didn't really. Here's my thing. I really think that this is enough from increasing to decreasing. But I'm going to look at the scoring guideline and we'll see. C, find the minimum value and the absolute maximum value on the interval -4 to 12. First of all, what do I need to check? But they're absolute, so I have to add something else in. Yep. So the absolute minimums and maximums can occur at the endpoints or where G prime switches signs. Can you guys tell me what are the potential ones then? So what do we need to do? -4, -2, 6, and 2. We're not checking here and here because it does not change signs there. All right, so if I have to do that many, let's, we're using this. I like to sometimes make a table, but I'm running out of room. I'll do it up here. So remember now, where am I plugging these into? Which function? G. Okay, so I'm using the integral now. Okay. So let's start with G of -4. That equals the integral from -2 4 f of g dt. Let's see here. Are you good with me? I'm going to flip it around, right? Because can I do this is on the right of that. All right, -4 all the way to 2. And then I make it, take the opposite of that. Don't these cancel each other out, so that's 0? Are you following this? The area of this is 1/2 2 times 4. 1/2 2 times 4. And then I make it negative. All right, let's do -2. So I'm going to continue this on the other side. This is the opposite of negative 2 to 2 f of t dt. All right, you guys, what's the area from negative 2 to positive 2 of that triangle? 1/2, 4 times 4, which is 8, but then it's going to be negative 8. All right, g of 6 is the integral from 2 to 6 of f of t dt. I do not make it negative, so what's 2 to 6? That one's positive 8. And finally, g of 12 is, don't these cancel each other out? Positive and negative. So it's going to be negative because it's below 1/2 2 times 4. This is negative 4. Okay. So that's all the work for that. Where are they? Or did I ask you to find them? Okay. So I'm going to write it this way. The absolute max is g of 6, which is equal to 8, and the absolute min is g of negative 2, isn't it? Which is negative 8. Now, here's the deal. This gives us kind of a snapshot of what's going on then, okay? Because didn't we check the endpoints? Yeah. So g of negative 4 is negative 4. Then at negative 2, it goes lower, and it goes down to negative 8. Okay. And then we could figure out, hopefully from that, where is g of x less than or equal to 0? Isn't it from negative 4 to 0? Do you know why? When I'm looking for g, I'm looking for when the accumulated area is negative, and he's right. So the area is negative. Even though it's positive here, it doesn't balance out until there. Okay, and so negative 4 to 0. Less than or equal to 0. Okay. And it goes negative again, right?
0 at 12. That's 0 at 12.
No, g of 12 was negative 4, right?
Yeah, negative 4, but then all that will cancel out. So 0 to 6 is 12, and then 6 to 12 is 12. Negative 12, so negative 12 to 12. Get back to the axis. Well, it's just because it's just the left.
Okay, can you say it again?
Because the areas from 0 to 6 are 12, and the areas from 6 to 12 are negative 12.
But you said from 2, right?
Yeah.
So it would be 10. It goes from 2 to 10, and then it's 0.
Well, because g of x technically is defined as this, okay? So what I was looking at was when we found these values, g of 12 is negative 4, right? So what